Pakistan is an agricultural country. Agriculture is the second largest sector of Pakistan's GDP and almost half of the country's labor force is employed by it. However, Pakistan's agricultural efficiency is among the worst in the world. This year alone, Pakistan has seen floods, locust attacks, and untimely rainfalls which have affected its agricultural stakeholders, which are farmers, markets, and agricultural economy, negatively. We must take measures to reduce the vulnerability and increase the efficiency of Pakistan's agriculture.
But how? SmartTom. We aim to make a smart greenhouse that will be collecting values of the environmental parameter through sensors, and actuators are placed to control these parameters. For the demonstration purpose, we are using aloe vera plant. However, we'll be working with the tomato plant from now on, as the tomato plant is sown in the month of January and February. As we can find a lot of research on how growth can be improved in the controlled environment, but such thing has never been practically implemented in Pakistan till now. So our main focus is to practically implement and show how much yield can be improved by this method. For this purpose, we have been working on hardware and software simultaneously, but our main focus was the hardware part. In the coming weeks, we will be working on the simulation part so we can develop a better understandable model for our system.
First here we have DHT11, which is temperature and humidity sensor. This black box contains the brain Arduino Uno, which is collecting the data from the sensors and sending it to ThinkSpeak server by a Wi-Fi module attached to the Arduino. The Arduino is powered simply by a USB port, which then powers the other sensor. Moving towards actuators, we have exhaust fan, which maintains optimal temperature. Then here we have a light-dependent resistor to sense the variations of light. In the soil of the plant, we have placed soil moisture sensor to monitor the moisture level of soil, and then we have the light inside the sheet which maintains the required light intensity. For this demonstration, we are using a candle to increase the temperature. As you can see, as the temperature increases from the set value, which in this case is 35, the fan turns on to keep the internal temperature stable. This part shows the light test. When the surrounding light goes out, the sensor detects the change and rapidly illuminates the greenhouse, ensuring optimal light for plant growth. As the soil moisture sensor is in the soil, we can use this software to observe the values. You can see the ThinkSpeak server window. The left window shows the serial monitor for locally viewing the parameters. The right window shows the real-time data which can be accessed remotely, and each parameter can be viewed thoroughly with respect to the time. This will help us in detailed monitoring. We aim to make this product more user-friendly by showing these values to the user on mobile application.
Now coming towards the software part. The screen shows the MATLAB simulation. The first graph shows the rate of change of fruit with respect to the temperature, and the second one is displaying the rate of change of leaves with respect to the temperature.
Our direct competitors in this field are XFarm for sensor implementation, Sensor Cloud System, and Auroras for wireless intervention and monitoring. We believe that SmartTom is the future of Pakistan's agriculture because efficient systems bring efficient production.